Tosunoglu. We're Team 15, and we're doing the Arabica Coffee Cherry Harvester.
I'm Kevin Ward.
And I'm Brooke Willen. And our academic advisor is Dr. Caesar Levy. And to begin on our agenda, we will be discussing our problem statement and our motivation behind our design, as well as the global issues that we are trying to address and the goals. As for our problem statement, there are two current ways of hand harvesting coffee. The first one is hand picking. It's a very slow process. The laborer has to pick each individual cherry by hand, and they have to collect 100 pounds in order to meet their daily quota. The second way is strip harvesting. So they have to strip the whole plant, and they gather ripened cherries and unripened cherries. This is going to affect the quality of the coffee in the long run, but it does meet their quota faster. This is harmful to the plant. So we want to create a machine that facilitates the picking without causing harm to the plant.
So the motivation behind our project was that we know there's other machines out there that can do the same type of process. However, the difference that stands out between their machines and our machines is that we want to make our device man portable, meaning that we want to make sure that it's light enough so that the farmers can carry it with them. As well as we also want to be able to decrease the child labor and increase the quantity of the amount that they're picking, as well as the quality of it. Some of the global issues that we want to be focusing on is the manual labor that it takes for these farmers to pick the cherries, as well as look into the economic aspect of it a little bit more, and the environmental conditions. So throughout the studies, we did notice that picking the cherries is very demanding. Therefore, we want to be able to go ahead and increase the amount of cherries that they're picking by our machine, meaning the time of it. As well as an economic aspect of it, the coffee industry is actually a $20 billion industry, which is second behind oil. Therefore, if we increase the quantity of our coffee as well as the quality of it, there could be an economic profit for the farmers that are doing it now. Also, for our project, the Arabica coffee cherries grows best in hilly terrains, which is why we're focusing our machine to be able to to be able to work in territories such as South America. This also will be able to allow our machine to be light enough, just in case it is, if it is supposed to be on hills, it's light enough that it won't fall over. So the goals for our project is that we want to be able to gather 70% of the cherries at prime maturity, as well as to make the machine portable, as well as decrease the labor time that it takes, and make sure that it is affordable still to small farmers throughout. And overall, this will improve the process of the picking of the cherries, as well as the quality of the coffee.
Okay, so a couple of important Arabica coffee cherry characteristics we would like to take note of include the strength range and the sessile attachment of the coffee cherry from immaturity to maturity. Sessile attachment simply means that the cherry is directly connected to the branch as opposed to having a stem in between. We like this characteristic. Basically, what you need to know is that it becomes weaker as it becomes more mature. The color range from immaturity to maturity ranges from green when it's immature and cherry red when it's mature. And also a third characteristic is that it grows in size as it matures. This is also a characteristic that we like. Some engineering applications that we will be using for our project include the quantification of the frequency of vibration of the mature and immature cherry. This is in order to aid us in quantifying the shearing force necessary to remove the mature cherry and keep the immature cherry on the branch to be picked at a later time. We'll also be employing a gearing system which will rotate at a particular revolutions per minute, and we'll be testing and modeling the product on SolidWorks so as to make it more efficient in its cherry picking process. Some engineering standards we will be referencing for this project include the Code of Ethics and Safety Codes from NSPE and ASME. This is to ensure that proper design practices are followed, and we'll also be referencing the others on the list.
So for our first design idea, we came up with a shallow bowl that will be planted close to the surface, and then you plant a seed along with it. So the seed will grow, and then the roots will intertwine through the holes with the bowl, and then you'll have an external remote that you can turn on to shake the bowl. When the bowl vibrates, the mature cherries will fall to the ground, and the laborer can collect it. However, one one pitfall that we see to this is that we don't know how the roots will be affected by shaking it at that point. So we came up with a second design idea.
Our second design idea consists of a rotating cylinder being placed about the fruit-heavy portion of the branch once it's maneuvered past the delicate portion of the branch. Once it's in place, we'll turn it on, and the cylinder will begin to rotate, as well as the cabin pin components that you see in the picture. Basically, we want to rotate at an equivalent revolutions per minute that will equate the force necessary to remove the mature cherry and keep the immature cherry on the branch, as we said before. Some design components that we've been contemplating as of late include some material choices. One being carbon fiber. We like it because it's durable, inexpensive. Durable, lightweight, 3D printable, yet it is costly. Another option would be an aluminum alloy. We like it because it's lightweight, durable, and inexpensive. A second design component we've been considering include the powering options. We would like to use solar panels. We like it because it's clean energy, yet it might not power the machine in a practical manner. A second option would be the gas-powered motor. We understand it's not clean energy, yet it will supply the necessary power needed and is more readily available. A third option would be a hybrid of the two, where it would ideally use solar power first, and then once that's depleted, it'll switch over to using gas power.
So as for the economic aspects, the current machinery looks like this. It's very large. It also is very expensive. It costs upwards of $1,000 plus. So we know that a small farm can't endure the labor costs plus the cost of a heavy piece of equipment. So we know that we need to keep our material costs low and also have less material so that in the end we can have a cheap design.
So as you can see, this is the timeline that we are following. For right now, we've done the majority of our research and literature surveys. We will continue to follow it as we approach fall and summer, whereas we will be focusing a little bit more on the manufacturing side of it, the design, the testing, well, finalizing the design and the testing of the machine. In conclusion, our goal is to gather 70% of the matured coffee chain berries from the plant, as well as for the design, it's to improve upon the designs that are already out there. One of them being land portable and making sure that our design is light enough for that to be able to be succeeded. As well as for globally, we want to be able to decrease the work that it takes right now to pick the coffee cherry beans, and as well as increasing the quantity without affecting the quality of the machine, of the coffee, I'm sorry. And that is our
Do we have any questions?
On your standards, seeing that this is going to be done or used in Nicaragua or similar coffee-producing nations, I didn't see where your standards were comprehensive enough to recognize some of those.
Well, we want to focus on high altitude locations. So it is most of South America. We haven't focused on any standards for testing in these particular countries, but that will be part of our report.
So you want to include a bullet item that other local standards to satisfy global issues,
Make sure.
that other local standards would be included. That would take care of that, in my view.
Are you planning to field test this concept? I mean, to your prototype?
Yeah, so we are in contact with farms in Homestead. So we're going to try to test it there. And if we aren't able to get a coffee plant, the next closest plant is a blueberry that we're able to field test that on, because that's more readily available in South Florida.
Yeah. Especially because if you damage the coffee plant, then it takes about 3 years for it to regrow. So sometimes a little bit time efficient that we don't have right now.
Well, I grew up in Homestead. My dad was a farmer. Looking at your design concept there, are you going like, say you get like a branch with a bunch of coffee grinds,
The
cherries. So you have to put one branch at a time, then it'll pick it, and then another branch.
Well, it's going to go through, and then the pistons are going to hit it at an optimal angle. They're going to fall and be collected,
Okay.
but it does need to go through every branch.
Right. Because I'm looking at that, and it's like, that's might be time consuming, but, you're gonna have to train the workforce how to correctly use this machine. Because plants, like you say, they take time to grow, and they're very sensitive to bombs and stuff, so you gotta kind of keep in mind when the worker doesn't hurt themselves until they hurt the plant.
Definitely a particular method we would like to use in order to reduce the time needed to pick the cherry is we want to place the pins in a particular orientation so as that the pins cover the range of importance, being obviously where you want to pick the cherry in approximately 3 to 5 rotations. We can't give you any real numbers but that would be an ideal goal for us.
I guess I have another question. How are you going to determine the optimal frequency of vibration for the ripened cherry so that you have a high degree of confidence that you're not shaking off the unripened cherry?
Right.
How are you going to determine
We
that?
plan on finding the range where it will be good for the mature cherry. We plan on finding through research.
There is research on it already, as
Okay.
well as we are going to do the field testing.
So
So,
kind of figure out
yeah.
which works best for the frequency.
Now, I have just a general question. You talked about scalability in a sense with farmer portability, but I'm not getting the understanding of overall intended size of your design.
so it needs to be man portable. So we are thinking maybe about like 20 pounds or so, and
The diameter will be less than a foot because we actually measured some leaf ranges on one plant that we were able to get in contact with, and it was about 9 inches. So it would be definitely smaller than a foot. But we also have to consider how far out the mature cherries protrude from the immature cherries, and that's going to give us the sizing dimensions for the pins.
the width.
Yeah, I mean, I think just even a simple visual, maybe of a plant with a relative scale to it, something that shows everybody generally, because I mean, this could be a 3-inch diameter, or it could be a 12-foot diameter, for somebody unfamiliar with the trees and the bushes.
Okay, thank you.
Just curious, so do you have any idea as to how to control that frequency,
How to make it
basically,
rotate.
what kind of, what's the electrical requirements that you have for this? What kind of control are you using for this? Because I suppose it's a manual thing where you have to, control your frequencies in such a way, or is it a fixed frequency when you find it?
It's going to be a
it's
one-step
done?
rotation.
Okay.
And what will be moving the components is the gearing system that isn't shown in the design. We would like to figure out the revolution per minute for the cam, pin component, and cylinder. If we can find the revolution per minute for both, that can make them both equal, that will equate the force needed, that would be better, because then we can use less material on the gearing design, and that'll be less cost.
But for terms of the prototype, to come up with that solution, how are you gonna vary your frequency, and then, because I assume you're gonna optimize the frequency, right?
Right, we don't plan on varying the frequency at all. We actually wanted to rotate at a particular revolution, and since each pin will be in different orientations, there will be a range of speeds that it will be rotating at. But this range of speed, we plan on fitting it inside of the okay speed of only the mature cherry and not the immature cherry. So a required strength is required to remove the mature cherry. We won't be getting to that point. We'll stay below.
Any other questions?
Well, you said you're gonna use probably a combination of solar power and a gas motor. Have you thought of probably maybe looking at an engine that runs on natural gas? Because that's also another big source of fuel for an engine. Have you thought about that?
We have thought of.
Well, we thought about that. We also thought about batteries as well, but we also need to look up to see what's readily available for the small farmer. So gas is ideal for them. We know it's not clean energy, but so I guess our next step would be for the clean, renewable. Yeah.
Right. Because agriculture has just
Yeah,
different.
different.
Different availability, yeah.
Right. 'Cause I think Brazil's like most of their vehicles,
Off the board.
natural gas, and
Yeah.
the rest are not.
Exactly.
Yeah, Brazil's actually the largest one.
So something that can be able to, maybe, like you said, that's great for one of the countries, but not necessarily for all the
Correct.
others.
Right. Right.
Okay.
Okay.